All right, remember we should always look at the given very carefully for a diagram. And for me, I need to remember when I have congruent triangles or congruent polygons, I have to play the matchy-matchy game. And it's okay for us to do that. So here they tell you that triangle CDE is congruent to triangle HIJ. Then they give us two segments, DE and IJ. So I look to see if those correspond, which means do they match? And the cool thing is they do. So I know that segment DE is equal to segment IJ because they correspond. So if I'm looking for X and I need to plug it back in for DE, I can now set up my congruency with them. I can go 9X is equal to 7X plus 3. Subtract 7X from both sides. And I divide by 2. Oh, look, a fraction. As long as it's reduced, leave it that way. So there's your X. A lot of you are thinking, it's 1.5. Please leave it as a fraction. Please get used to working with fractions. Then I just have to plug it in to find DE. So remember that's 9 times 3 over 2. Now if you need to, change that to over 1, so that way you know when you're multiplying across, numerators go together, denominators go together. So that's 27 over 2, or 13.5. And there's DE. Let's do our next one while we're working with it, okay? The next one, it says triangle CDE is congruent to HIJ again, so I know they're congruent. And now this time we're talking angles. Well, what do we know about corresponding angles? They're congruent. And there will always be a pair that you know that should match together when we're doing these problems. So I know D and I are going to match up. So I go here and I'm like, oh look, the measure of angle D and the measure of angle I are exactly the same. So I plug it in. 5y plus 1 is equal to 6y minus 25. I don't like the look of that, so I'm going to get the y there. Now we just have to solve for y first, and we have to plug it in. So I'm going to add 25 to both sides. And I get 5y plus 26 equals 6y. And just go ahead and subtract 5y from both sides. 26 is equal to 1y. So that's y, but I need to plug it in for the measure of angle D. So we're going to plug and chug, my friends. So we get 5 times 26 plus 1. So 5 times 26, 5 times 26, what do we get here? 130 plus 1, we get 131 degrees. It works out pretty easily. Now, we are still going to have to do proofs, and this chapter is like the best chapter for proofs ever. It allows us to work with these over and over again, and we want you guys to be able to work with proofs on this. But we have to be able to prove it. Now, I'm going to do it the hard way. We're going to find shorter ways of proving triangles congruent. But remember, to prove that triangles are congruent, we have to get all corresponding sides congruent, and we can get all corresponding angles are congruent. So we have to fulfill all of those. So we're still going to do our proof, and we're still going to, I'm going to have to write pretty small on this. So we'll still have our statements, and we'll still have our reasons. So remember, we always want to make sure we mark up our givens and write stuff down that we have, okay? So we're supposed to prove that triangle XYW is congruent to triangle ZYW. So that means we want to make sure everything matches when we do this. So the first thing we always start with is our given. And we know that angle YWX and angle YWZ are right angles, given. Now, what do we know? Now, remember, we have to show every corresponding part congruent. So if I'm saying that they're right angles, what do we know about all right angles? They're congruent. So you can say YWX is congruent to angle YWZ because all right angles are congruent. So we have those now congruent to each other. So we have one pair of congruent angles. Now we have to get two other pairs. So let's do the next one. We go back when we work with it. And we have in our given that segment YW bisects angle XYZ. Now, if I give you an angle bisector, you give me two congruent angles. So we know the angle XYW, and you want to matchy-matchy these when you work with it, okay? XYW is to ZYW, and that's because the definition of an angle bisector. Now let's go with it a little bit more. Now I need a third pair of angles, but we had a theorem on today's lesson that helps us do this. We know, because the other two pairs of the triangles are congruent, we know angle X is congruent to angle Z. And then we just say if two angles of one triangle are congruent to two angles of another triangle, then they are congruent. So it's not too bad. So now we know that these two are congruent to each other. So we have all the congruent sides. Let's do another one here. Remember, I have to have 3 pairs of congruent angles, 3 pairs of congruent sides. The cool thing is, starting tomorrow, we're going to start finding shortcut ways of doing this, so it's like so cool. So at the number 6, I'm going to go back to my given again. They tell me W is the midpoint of segment XZ. If I give you a midpoint, what do you give me? 2 congruent segments. So that's what I'm going to say after my given. We're going to say next. Segment XW is congruent to segment ZW. Now notice I'm matching my correspondence even with my vertices when I name these. And that should be just the definition of a midpoint. Now we're given one other given here. Number 8. We're given that segment XY is congruent to segment YZ. So these I know are congruent. Good. Now I have 2 pairs of congruent sides. I need a third pair. Well, here's the cool thing. They share YW, so YW doesn't share sides. And so now I go, all right, segment YW is congruent to segment YW, and that's the reflexive property. So the cool thing is, I know, therefore, I have 3 pairs of congruent angles, 3 pairs of congruent sides. I'm going to mark it like this because it's reflexive here. I have 2 congruent triangles. Now the cool thing is, this is hard, but we will get a shorter method of doing these later. But notice how I named these. X and Z had to match up. W and W had to match up. Y and Y had to match up. And this is just by the definition of congruent polygons. Alright, hopefully this gives us a start on working with these, and we should be able to talk more about them on Monday.